All right, so welcome Amir Samari, a manager of solutions architecture here at InterSystems. Thanks for joining us today, Amir. You're going to be telling us about a speed test with InterSystems Iris. So before we dive into those details, why don't you tell us a little bit about kind of the nature of a speed test like this and what we're really going to be looking at?
Well, thank you for having me, Derek. The speed test is at GitHub. You can find it here, Iris demo age tab. You can also find it on Open Exchange. And the idea behind the speed test is to show a specific use case where data is coming into the database very fast, and we want to measure if the database can still answer to queries. So if you look at the GitHub page, you're going to find a lot of information, some results of the speed test, like with SAP HANA, InterSystems Iris, compared to SAP HANA. So we ingested data 60% faster, while we were retrieving the data from the database more than 2,000% faster than SAP HANA. And we have similar results here for MySQL, SQL Server, Sybase, Postgres, MariaDB, and this test can also be run on AWS. When we run against Postgres, MariaDB, and Sybase, we were running all on AWS. We were picking their managed services offering. So for instance, when we were running against AWS Aurora, we were deploying AWS Aurora on AWS. And it is a managed service, well-tuned by AWS, so it's a fair comparison. So if you keep going here, there are instructions on how to run the speed test on AWS, how to run the speed test on your PC. We are going to be doing this shortly, but I'm just scrolling down because I want to use a picture here that explains what is going on. So as I said, the speed test is about a specific use case. It's not a general benchmark about speed. It's for a specific use case where ingestion or data is being sent to the database very fast. And we call this ingestion, an ingestion use case. And there are applications here that is also trying to query this data in real time. So that's the use case. Data coming in very fast and applications querying the database in real time. This is like a picture of a typical in-memory database. And as data is coming in very fast, the in-memory database will try to keep the data in memory. It will write the data to the database log. This is the transaction log, so that the data is guaranteed to be durable in case the database crashes. And as a lot of data keeps coming in, data is going to be maybe compressed in memory, but eventually the database will be obligated to push some of that data out of memory and into the disk. So even an in-memory database eventually ends up writing data to disk when under pressure. So if you are trying to query that data here, there is a inverse pressure going on here. This inverse pressure is about, well, you keep querying for those records, those yellow bricks here, and those yellow bricks there, let's say. So a smart database will try to keep those records in memory, right? If those records are pushed into the database file out of memory, it will take longer to bring them back and answer to your query. So we are trying to measure these things. So how fast the database can answer queries under pressure. So that is what the speed test is about.
Right. So kind of taking this generic concept that we hear a lot about speed, like how fast is your database? How fast is this technology? And really distilling it into this use case of both heavy data ingestion. I know we've sometimes referred to it as high performance data ingestion, where you have a lot of data coming in and making sure that that doesn't have an impact downstream when you're actually then trying to query that data, and making sure that those pressures, like as you explained, the inverse pressure doesn't slow everything else down. So that's kind of the crux of what this test is going to show us, right?
Yes, because any database can perform on normal situations, like when there is no high volumes of transactions, right? And we may not be like the fastest database on some specific complex joins, for instance. There is always something that a database will do better than others, okay? So you have to look into your use case. But under pressure, things are different, okay? If you can't answer queries under pressure, it doesn't really matter if you are very good at those joins, or you have those smart indexes or columnar storage. If your database freezes under pressure, nothing's going to work, right? And so we are putting the database under pressure, and let's see how they perform, right? If all those bells and whistles will really keep working under pressure.
Yeah, right. Under a sustained workload. Cool. Let's take a look. Let's see it.
All right. So if you scroll up on the GitHub page here, you're going to see instructions on how to run it on your PC. The easiest way is just to copy this URL and use the command git and clone this repo. So this is going to create a folder on your PC. You're going to need also Docker, because this is a Docker composition. And then you can just say Docker compose up to start the test. So here, for instance, I have a terminal open, and I can say Docker compose up. And it's now starting Iris, InterSystems Iris, and starting the speed test. It has a user interface and a nice UI that we will be using to drive the test.
Cool.
We need to wait for this screen to stop moving, all these logs to stop, and then the test will be up. It takes only a minute.
Yeah, so this is basically spinning up all the pieces that we're actually going to operationalize here, with ingesting some data and then querying it and running that all through InterSystems Iris in this Dockerized form, correct?
Exactly. The UI of the speed test is an Angular application, while the speed test itself, it's a Java application. So we have the UI driving this Java application that is trying to overload the database with records. So there you go. We have it running. So here is the UI, and I can refresh this screen. And here on the title, you can see that this is Iris Community 2020.2. You have a settings button here that you can use to configure a speed test. Maybe you want to increase the number of threads or connections that are sending data to the database. Maybe you want to increase the number of threads that are querying the database. And you have other things you can change here. Or you can just hit run, and this is going to start the test. It takes a couple of seconds to start with InterSystems Iris. There you go. So what is going on here? So here in this square here, you're going to see the ingestion rate. So how many records per second are we sending to the database? So the green line is the average, the blue line is the instantaneous ingestion rate. Here is the same in megabytes per second. So this is running on my PC, and we are recording a video which is resource intensive. So this is going to steal some resources from the test, but that's okay. And here is the query rate. So we are doing here about a little bit less than 1,000 records per second, which is very slow. So we can stop the test and maybe just try to increase the number of threads here to 2, for instance, so we can get a higher rate. And that's the kind of things you can do. You can play with the task, maybe try to use more threads. You see now we're doing a little bit more than 2,000 records per second at query rate, while doing a little bit about like 20,000 records per second on ingestion rate. Here is also the average query time. This is like how long does it take for a single record to be returned from the database. It's like the latency, right?
Right.
So if I stop this,
and
go ahead. I'm sorry.
Yeah, one thing I wanted to ask. What's interesting, I think, tying back to something you said before, is dealing with that ingestion coming in on the front side of this architecture where you're ingesting a bunch of records. It's interesting, and I think encouraging. Correct me if I'm wrong. To see that you're not seeing a steep drop off as you go through in time, right? Like as time passes, you're not seeing a steady decline because of the ingestion coming in. It's able to handle and maintain its speed pretty well, even with a bunch of records coming in every second, right?
Exactly. It's sustainable, right? It's a sustainable query rate and a sustainable ingestion rate. It doesn't degrade.
Right.
Actually, the official results of the test, we run this test for 20 minutes. Because sometimes at the beginning of the test, everything is wonderful, but then things start to degrade with time, and you really have to wait and see how the database is going to be performing. So we actually run the test for 20 minutes. Okay.
Nice.
So the results here is a CSV file with several columns measuring ingestion rates, number of threads, megabytes per second, everything you need to plot your own graphics on Excel if you want. But let's see how another database will perform here, right? So we just run the test with InterSystems Iris. Let's run it now with MySQL. There is a script you can use here as well, just the run script, where you can say, for instance, MySQL. And it's just a shortcut for a very long Docker compose up -f Docker compose dash mysql.yaml. So it's it's very convenient.
Saves you some typing. Yeah.
Yeah, and it is on the GitHub page as well. So everything's very, very well documented. So you see MySQL being started here.
So this is basically the same steps as before, but now using MySQL instead of InterSystems Iris, correct?
That's it.
Yeah.
And you don't have to have InterSystems Iris installed or MySQL installed. This is a Docker Compose application. So they are pulled from the internet in real time. And when you are done running this, they're not there anymore. They are deleted. So it's not like we're taking space out of your machine.
Yeah, a very lightweight solution.
Yeah, it's not like we're contaminating your PC with a bunch of software. It's very clean. So there you go. It's up again. So now if we just refresh this screen, right? Remember 30,000 here, about a little bit above 2,000 there. Let's just refresh this. So now it's saying MySQL, and we can just hit run. Oh, it looks like something happened to, oh, there you go. I have to say this is much slower than usual, probably because we are recording, and but it's not too far from the truth if you look at the results we published on GitHub. So 30,000 from Iris, 1,000 for MySQL, right?
Yeah,
and the query rate here for MySQL is just 200, 300, right? 300 records per second. And look at the latency. We were under zero there. Here is how much?
Huge difference.
Almost 3 milliseconds. So it's much higher, much slower query rate. But MySQL, if it gets better if you give it more more threads. So like let's just jump this to 5, for instance, and 5 there, and you can just run it again, and it's now kind of warmed up. Probably you'll see better results, and you can play with that. So the query rate increased. You see, it's a little bit better.
Yep.
And the ingestion rate,
and those numbers
didn't change much.
A little bit better as well.
So we are kind of 15 times faster at ingestion than MySQL. But running on your PC just gives you an idea of how fast the InterSystems Iris is when compared to all these databases. We can run the same test with MySQL, MariaDB, Postgres, SQL Server, and Sybase, all on your PC. So you can test all these databases. But the real results, when you look here at the GitHub page, we have all these results. Those were all run on AWS with much better hardware, with managed service deployment of these databases. So, for instance, when go ahead.
Yeah, I was going to say a much more dedicated setup where you don't have to worry as much about resources pulling from what's going on. It's really actually very pure as far as testing really what the heart of the test is aiming at, right?
Not only that, but it's also a very well-tuned deployment of MariaDB, for instance. It's the best configuration of MariaDB that you could get, because that's what you're paying for. If you are asking for an M5 2x large machine with MariaDB on AWS, AWS will give you the best configuration of that database for that machine for you. So, and that's what we're comparing with. If you click here, you're going to see all the details, like how we set up that test, how we provision the machines on AWS, up to the point we help you to deploy MariaDB step by step on AWS. And these are the results here. We picked an M5 2x large. We run the test for 20 minutes, and Iris ingested 620% more records than MariaDB
in that time,
Yeah. So it's a much faster than MariaDB on this use case, right? Where under pressure, ingestion and query under pressure.
Right. Very cool. Looks like there's a lot to explore there, and to really explore it against a bunch of different alternatives. And like you said, on your own machine, or you can run it on AWS as well. So that's a lot of good stuff. Any other final thoughts people should know about trying this themselves to be able to, really experiment with it and play around with it?
Well, this gives people a very good idea of InterSystems Iris speed. But I always want to make sure people understand that this is a very specific use case. It's not a general speed test. Like we have other benchmarks that are for other use cases. This is a use case that is very common on financial services, IoT. In financial services, we may be talking about credit card transactions, equity trade transactions. In IoT, we may be reading signals from thousands of machines on a city. And this is ingestions, data coming in very fast. And then there are all these use cases where you have to do anomaly detection, fraud prevention, and you are trying to do that as quick as possible, because otherwise, someone is going to steal your money, or someone, something very bad is going to happen. So you're trying to do these queries and fetch this data and use it very, very fast. So this use case where you have high ingestion and querying real time is what we are putting to the test here. And InterSystems Iris has been consistently faster than these other databases.
Right. Very cool. Well, Amir, thank you so much for walking us through that, and can't wait to try it on our own. So thanks again.
No, thank you. Thank you for your time.